FRM Part 1 Quantitative Analysis. Let us start with aim statement 12, Review of Probability. Under this we are going to define random variable and understand the difference between continuous and discrete random variables. We will define the probability of an event and also learn to calculate, define and interpret the mean, standard deviation and the variance of a random variable. We'll also understand the skewness and kurtosis of a distribution. We'll also describe joint, marginal and conditional probability functions and understand the difference between statistical independence and statistical dependence of different events. Then we'll look at the mean and variance of sums of random variables. Then we'll describe the key properties of normal, standard normal and multivariate normal distributions. We'll also look at chi-squared, student t distribution and f distribution. We'll describe random sampling and understand what is the meaning of IID, which is independent and identically distributed random variables. Then we'll look at the mean and variance of sample average. And finally we describe, interpret and look at the law of large numbers and central limit theorem. So let us start with random variable. Random variable is the one which holds the value of the outcome of a random event. Suppose tossing a coin is a random event and the outcome is head or tails. So there is a random variable which can hold either heads or tails, which is an outcome of a random event. Similarly, if a random event is throw of a dice which has 6 faces, so the random variable can hold any of the 6 values from 1 to 6. Now random variable can be of two types, discrete random variable and continuous random variable. Discrete random variable can hold only discrete values which are fixed numbers. For example, heads or tails when we are tossing a coin, or when we are throwing a dice, it could be 1, 2, 3, 4, 5 or 6. So the number of values which this random variable can store are limited and fixed. So this is called discrete random variable, while there could be a continuous random variable. For example, there is a random event which could be rainfall on a particular day. So this is also a random variable, but this can hold a large range of values or infinite number of values. For example, if the rainfall could be between say 2 mm to say 200 mm, so it can have any value. It does not need to be an integer. It could be 2.5343 or it could be 2.78 or it could be 192.794. So there are infinite values between them. So it can hold any of those values. That is why when we talk about continuous random variables and their probability distribution, we look at cumulative distribution instead of probability distribution directly. Now let us look at the probability itself. Probability of an event is nothing but the likelihood of the occurrence of an event. So what are the chances, what are the likelihood that a particular event can occur? So this can have value between 0 and 1. 0 when there is no chance of occurrence of the event, and 1 when it is 100% sure that one particular event is going to occur. Now the negation of an event, the probability of particular event not occurring is 1 minus probability of occurrence of that event. For example, if the probability of occurrence of 1 while throwing of a dice is 1 by 6, then probability of not occurring 1 is 5 by 6, which is 1 minus 1 by 6. Okay. Now sum of the probabilities of any set of mutually exclusive and exhaustive event is going to be 1. So let us see what are mutually exclusive event. These are the events which cannot occur together. For example, in this case, either 1 can occur, or 2 can occur, or 3 can occur, and so on. But any of the two numbers cannot come simultaneously. So these are mutually exclusive events. And exhaustive events cover all the possibilities. For example, if we look at the sum of these probabilities on a throw of dice, then probability of occurrence of 1 plus probability of occurrence of 2 plus probability of occurrence of 3 and so on, all the probabilities, sum should be 1. So in this case, each of them is 1 by 6 and we have 6 cases. So sum of it is going to be 1. Similarly, if we talk about toss of the coin, then heads and tails are mutually exclusive event and both are mutually exhaustive. There is no other possibility, either head can come or tail can come, sum of which should be 1. So sum of the probabilities for any set of mutually exclusive and exhaustive event is going to be 1. Now let us look at the conditional probability. When we say probability of A, which is conditional probability when B has already occurred. Probability of occurrence of A where given B has already occurred. So that is called conditional probability. Here occurrence of A is conditional on occurrence of B. That is why it is called conditional probability. Another kind of probability is unconditional or marginal probability. When we say probability of A, which is not dependent on any other event, it is not conditional on whether event B has already occurred or has not occurred, it is called unconditional probability or simply probability of occurrence of event A. So we need to be clear with these conditional and unconditional probabilities difference. Now let us move to the next concept, which is joint probability and multiplication rule. So when we know that we need to calculate the probability of both event A and B occurring simultaneously, which is joint probability. So what are the chances that probability of joint event when A and B are occurring together? So this is called joint probability and it is given by the multiplication rule, where first is conditional probability of A where B has already occurred into unconditional probability of event B. So this is the rule which we need to remember in order to calculate joint probability. So let us take an example. If there is a deck of 52 cards and we need to find out what is the probability of randomly selecting a card and it being king of heart. So there are two events, king and heart. Both are not independent of each other, both can occur simultaneously, so they are not mutually exclusive. So we need to find out what is the joint probability of these two events. Let us say being a king is event A and being heart is event B. We need to find out joint probability AB. So that has to be given by probability of A given B, conditional probability, into probability of B, which is heart. So let us see PB first. So what is the probability of a card being a hearts card? Since there are total 52 cards, out of which 13 are heart, so 13 by 52 or 1 by 4 is the probability of card being a heart card. And now once it is given that card is of heart, what is the chances of it being king? Since total there are 13 cards and only one is king, so that probability is 1 by 13. So probability of A given B, conditional probability is 1 by 13. So 1 by 13 into 1 by 4, or it is 1 by 52. So this is the probability of event A and B, or joint probability of A and B. It can be taken other way also. Suppose being a king is event B and being a heart is event A. So in this case, probability of A given B is going to be, so if it is a king, what is the chance that it is going to be a heart? Is 1 by 4. Okay, there are 4 cards of king, one of them will be heart, so it is 1 by 4 into probability of a card being a king, being a heart. Probability of B is going to be, probability of king is going to be, there are 4 kings out of 52. Since it is unconditional, we are not looking at any condition, so it is going to be again 1 by 52. So we can calculate it using either way. So this is how we understand joint probability and multiplication rule. We can also write it as probability of B given A into probability of A. So it does not make any difference. Now let us look at one more rule. Probability of at least one event and addition rule. What is the probability of at least one event? Earlier we were looking at joint probability where both A and B are occurring simultaneously. Here we are talking about at least one. So probability of at least one of the two events occurring, A or B. So that is given by probability of A, unconditional probability or margin probability, plus probability of B minus joint probability. So let us calculate the probability where A is king and B is heart. Again the same case out of a deck of cards. Now we have to calculate the probability of a card being king or heart. We know the probability of card being a king is, there are 4 kings out of 52 cards, it is 4 by 52, and probability of being a heart card is 13 by 52. Okay, there are 13 cards of heart. Now we have already calculated probability of PAB, which is joint probability, which is 1 by 52 as we have already calculated. So probability of a card being A, king or heart is 4 by 52 plus 13 by 52 minus 1 by 52. So it is going to be 16 by 52. So that is our answer. Now let us look at certain specific cases of multiplication rule and addition rule, where the independent events are there, which means the occurrence of one event is independent of the other. So the conditional probability is same as the marginal probability. For example, probability of A given that B has already occurred is same as probability of A. So probability of A is independent of whether B has already occurred or not. Similarly, probability of B given A is same as probability of B. So in this case, we know that A and B are independent events. For example, if we are tossing a coin, if we are tossing a coin 3 times consecutively, every time the possibility of head or tail is going to be independent from other tosses. So these are independent events. Let us look at mutually exclusive events. We have already seen the events which cannot occur simultaneously, or the joint probability of these events is 0. They cannot occur simultaneously. These are known as mutually exclusive event. So now it will be clear for independent events. If we look at the multiplication rule, it is simply going to be PAB is equal to PA into PB. As we already know that PA given B is simply PA for independent events. That is why the joint probability is just the multiplication of the two. While if we look at the mutually exclusive event where the joint probability is 0, the probability of at least one event A or B is nothing but probability of A plus probability of B, since this term is going to be 0 here. So that is why for these events the multiplication rule and additional rule gets further simplified. So it is just the product of the two and this is just the summation of the two. but the condition of independence and mutually exclusiveness need to be remembered. Now let us look at the next concept, which is Bayes formula. This is very important probability concept. In order to update a given set of prior probabilities for a given event in response to the arrival of new information. So that is where the Bayes formula is used. Suppose the probability of certain event was given, now a new event has occurred. We need to update the probability. How? The probability has been changed now. For example, the unconditional probability of a new information is PB. So earlier, prior probability of an event was PA. Prior probability was PA. Now a new information unconditional probability is PB. Now we need to know what is the probability of event A given B has already occurred. Now this is the update. This is the change which has occurred. Now we need to find out what is the impact on A. What is the probability A given B has already occurred. So this is given by Bayes formula. In numerator we have probability of B given A, probability of new information given the event divided by probability of new information, unconditional probability, into prior probability of event. This is also unconditional probability. So we need to remember this formula so that we can find out updated probability when a new information is coming up. Let us take an example here. Suppose probability of A is probability of stock price of a stock A going up, and say probability of B is probability of GDP rise being positive. Suppose this is quarterly GDP. So if the quarterly GDP number goes up, that is the probability B. Now suppose the probability of B is 0.6. So probability of negation of B is 0.4. So GDP will grow, the probability is 0.6, and GDP will fall, the probability is 0.4. Now let us look at the conditional probability. Given that the GDP has gone up, what are the chances of stock price going up? Suppose they are 0.3 and the chances of stock coming down are 0.2. Given that GDP has gone up. Now if the GDP has gone down, the chances of stock going up are say 0.1 and chances of stock going down is 0.4. So this is the conditional probability. This is probability of B. This is probability of A given B. So this is the probability of stock going up when the GDP is already positive. So if we want to calculate what is the probability of GDP being positive where the stock has gone up, this information is already known. So we can easily calculate it using the same formula. We can just reverse it. So this is going to be probability of A given B into probability of B divided by probability of A. So we can easily put these values. Probability of A given B is 0.3, probability of B is 0.6, and probability of A is to be find out. We can find out from this. There are two cases where A can occur. One is this where the market has gone up. Another is this where market has gone down. So probability of A, stock price going up, is 0.3 plus 0.1, which is 0.4. And the probability of stock going down is 0.2 plus 0.4, which is 0.6. So we need to look at this one, 0.3 plus 0.1. So we can easily calculate. So it is 0.45. So this is how we can use Bayes theorem in order to calculate the updated probability. So let us move to the next concept, the probability distribution. Probability distribution provides the probability of all possible outcomes for a random variable. For example, A is a random event. So probability distribution of A will tell us how does the probability of A vary for different points. It gives the complete picture of all possible outcomes and their respective probabilities. So the probability distribution can be of two types, discrete and continuous probability distribution. So when we say we are tossing a coin, so probability of that event is given by 1 or head or tails. There are only two possibilities. So this is the probability distribution. It is giving us probability of all possible outcomes. So it is going to be like this, 1 by 2, 1 by 2. So for head it is 1 by 2, for tails it is again 1 by 2. But there could be a continuous probability distribution where we cannot define the probability at a particular point. So we need to look at the probability between a range. For example, if it is a continuous probability distribution, we can see what are the chances of the number being between say 2 and 2.4. So this probability is given by area where this graph represents probability density function. This is probability. So when we talk about continuous probability distribution, we need to talk about ranges. Now let us look at these functions. The simplest one is probability function given by Px. This is the probability of x being equal to a particular value. So this is probability function which gives the probability directly, mostly useful for discrete probability distribution. Then we have probability density function. This represented by small fx, this is the density of probability. So if we multiply it by this value, this range, or integrated over the range, we get the area, which is the probability. Then we have cumulative distribution function, which represents the probability of a number being less than a certain number. So random variable can hold a value of particular number. For example, we can say at this point, suppose this value is 2, the cumulative distribution function will tell us what is the probability of a random variable holding a value less than 2. So this will be represented by this area. So this is useful in continuous probability distribution, where probability at a particular point is going to be 0. For continuous probability distribution, probability of a number being a particular value is 0 because it is going to be very small. The continuous random variable can hold infinite numbers. So the possibility or the probability of one particular number is going to be 0. That is why we need to look at cumulative distribution function, and we can talk about the range over an area. Another important probability function is discrete uniform probability function. So this is discrete, it can hold only a few values, and it is uniform. Uniform indicates that for all the cases the probability is uniform, is same. For example, for toss of a coin, probability of all possible events is same. There are only two events, so probability of heads or probability of tails is just 1 by 2. Similarly, probability of 1, probability of 2 and so on for throw of a dice is going to be 1 by 6. All of them are equal. So they are uniform distribution. Now let us move to the next concept, the mean, standard deviation and variance for a random variable. For a random variable, we have a concept of expectation. This is a another way of looking at mean, which is given by summation of the values and their respective probabilities. For example, if there is a stock A for which there are different probabilities given, it can have 10% return over a period. For this, probability is 0.4. It can give 8% return, the probability of 0.1. Then the stock can also give minus 3% return in certain case, for which the probability is 0.5. So these are the three cases. If we add them, we get 1. That says this is mutually exclusive and exhaustive events. All possible cases have been given. So all we need to do is just multiply these numbers and add them up in order to find out the expectation of return of stock A. So what are the expectations? 10% into 0.4, 4%, plus 8% into 0.1, 0.8%, minus 3 into 0.5. So that is minus 1.5%. If we sum this up, we get 3.3%. So this is the expectation, or in other words, we can say this is the mean returns which is expected from this random variable. Now let us look at the variance of random variable. It is given by expectation of the difference between the random variable and the population mean square. So that is given by variance, where mu is nothing but the expectation, which is the mean. If we look at the example which we just discussed, there is a lot of variation in the possibilities. Stock A could give 10% return, it can give 8% return, or it can even give minus 3% return. So how do we capture this variation? For that, we have a parameter called variance. We can calculate it, how much variation is there in each of the cases from the expected value. Expected value is 3.3%. So it is, in first case, much higher than the expectation. In the second case, somewhat higher than the expectation, and the third case, much lower than the expectation. So there's a lot of variation. How do we capture that? So variation from this can be captured as variance of this random variable A can be given by the expectation of x minus mu square. We know the expectation is summation of the value into probability. So we can simply write it as 10 minus 3.3, which is 6.7%. This is the difference, and we have to just square it and multiply by probability, which is 0.4, plus 8 minus 3.3, which is 4.7, square into the probability, which is 0.1, and finally minus 3 and 3.3. So difference between these two is minus 6.3. As we see that sign will not make any difference because we are squaring the value. So the variance is going to put equal weightage on the variation on both sides. So into probability 0.5. So if we just add this up, we get variance of this random variable A. If we simplify this formula, we can have a simplified version. So we can write it as expectation of, if we just open it up, x square plus mu square minus 2 mu x. So if we further expand it, this becomes expectation of x square plus expectation of mu square, which is nothing but mu square itself. Since it is a constant, it is not a random variable. Expectation of a constant is same as the value of the constant, minus 2 into mu into expectation of x. Mu has come out because it is a constant. If we further calculate, expectation of x is nothing but mu. So we can write it as expectation of x square plus mu square minus 2 mu square. Since it is also mu, if we further Simplify this, we get E expectation of x square minus mu square. This is our simplified version of the formula. It can be given as variance of x is expectation of x square minus mu square, where mu is expectation of x. Now another parameter of the variation in a random variable is standard deviation, which is nothing but the square root of variance. So it will be calculated in the same way. We just take the square root in order to find out the standard deviation. Let us move further to a new concept, which is skewness. When we look at the normal distribution function, it does not have any skewness, since in this distribution the value of mean, median and mode is same. This is zero skewness, or distribution is symmetrical. Left hand side and right hand side are nothing but the mirror image of each other. So here in this case skewness is 0, as in the case of normal distribution. So we can say in other words that skewness refers to the extent the distribution is not symmetrical. Here it is perfectly symmetrical, so skewness is 0. Let us look at the cases where it is not symmetrical. Look at the first case. The data is positively skewed or right skewed. There is more data on the right hand side as compared to left hand side. That is why the mean is more than median, which is more than mode. So mean is greater than median, greater than mode. This is for positively skewed data. Here it is asymmetrical. Both sides are not the mirror image of each other. It is positively skewed data. Similarly, opposite case will be negatively skewed data or left skewed data. There's more data on left hand side. So that is why the mean is going to be less than the median, which is less than the mode. So mode is going to be the highest in the case of negatively skewed data. So this was about skewness. Now let us look at another property of data, which is kurtosis, which measures the peak of the distribution. So there are three cases. First is, let us say, mesokurtic. This is the distribution which has same kurtosis as normal distribution. We know that the normal distribution has kurtosis equal to 3, or in another words we can say excess kurtosis is 0, because excess kurtosis is nothing but kurtosis minus 3, which is for normal distribution. So excess kurtosis is how much excess is there with respect to normal distribution. So if this is the case of normal distribution, let us see what will happen if it is leptokurtic, where the kurtosis is greater than 3 or excess kurtosis is positive. So it will have more peak than the normal distribution. So it will have fatter tails and higher peaks. So there will be more data here and at the peak, but it will be taller. So this is called leptokurtic data, or excess kurtosis greater than 0 or kurtosis greater than 3. The opposite case will be platykurtic. This is the distribution which is less peaked than the normal distribution. Kurtosis is less than 3. So this will have flatter peak like this. So the more data is going to have here, the peak will be flatter. That is platykurtic kurtosis. Now let us look at the formulae. So if you want to measure skewness, we have the value of random variable minus the mean or the expectation, cube of that, divided by the sample standard deviation, and n is the number of element. Similarly, for kurtosis, we have summation of xi, the value of random variable, minus the expectation of random variable, to the power 4. Here we have third power. For kurtosis we have fourth power, divided by n, number of elements, s to the power 4, where s is again sample standard deviation. So this is how we can calculate the skewness and kurtosis.